There we go. So I think we left off last time talking about obviously critical thinking and talking about how our brains, well, in our information society that we kind of live in now, where we have social networking and we're constantly on our electronic devices and we're constantly being bombarded with information. That one of the things that's very difficult to do is how should I put this? Because we have information overload basically nowadays. We have so much information that's coming at us from all kinds of different media, all kinds of different things that a lot of times we're not even asking for, because a lot of social media information gets pushed to us, right? So there's two ways to get information when we're using the internet. One way is we go find it. So we use a search engine, we type in a query, and we look for information, we get some results, and then we read about whatever it is that we're, interested in. The other way is information is pushed to us. So the first way, when we go out and look at stuff, is we're pulling information. So we're the one that are initiating the information coming to us. So that's called pulling. So we're pulling things from the internet. The other way is when information is pushed to us automatically. So I know on Twitter, if you follow somebody, and by the way, a lot of other social media works the same way. If somebody is your friend or you follow somebody, whenever they post something, boop, it pops up. When you go to Instagram, right, you see some things, although Instagram is kind of pulley too, but it does push. So what other people are posting comes to us, even though we may not be interested at the moment. So we're getting a lot of information that we're not even asking for actively. We ask for it at some point by becoming a friend or following somebody. So that's a very different way from the traditional pull way of getting information, pulling stuff to us. And it's a little bit unprecedented in the history of the world, because most of the time information has been pulled. So back in the old days, newspapers were the way that people got information. There was no television, there was no radio. We got newspapers and books. And so that's a traditional pull method, right? You go buy the newspaper, or it comes and it's delivered to you, which is a bit pushy, but and then you read. And in the old days, I guess there were a lot more people that read the newspaper from cover to cover, from page, every page of the newspaper. But as we got more news sources, what would happen is people would just read the articles that they were interested in. And so we were already picking and choosing what we thought we wanted to know about, or what we wanted to know about. Then we got radio, and radio and television is very similar, because the information is being pushed in one aspect, but you don't see it or read it or hear it unless you turn on the news. So on the radio, the news would come on at a certain time, or even on television, and then you have to actively turn it on and watch it. So you're still kind of pulling. The difference is with radio and television is that somebody else is deciding what news that they're going to report on. So in that aspect, it's a little bit limited. and they're pushing certain news items. That makes sense, right? Some of you I can see, so you can nod or no. Angela's just staring. She's like, oh, it's early yet. And don't make me nod or say yes or no. So traditionally, you know, that pulling of information, by the way, reading a book, you would go buy a book or go to the library and find a book about what you were interested in. And I remember vividly in elementary school, you know, we'd have library day where you'd go to the library and you could get a book or two or three. It was like once a week or once every 2 weeks. And I remember being interested in dinosaurs when I was, you know, in 4th grade, 5th grade. Yes, I'm a typical boy. And so, you know, I'd get books on dinosaurs or airplanes. My dad was a pilot, so I'd get book on airplanes. Yeah. And stuff like that. But I'm pulling information, right? I didn't get a book that I wasn't on a subject that I wasn't really interested in. The only time I did that was when we were required to read something. I don't want to read, you know, blah, 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 but we have to. So, you know, traditionally, that's how information was used. And even further back, information wasn't really quote unquote news, it was somebody else's experience. So somebody would go to a different town or they'd go out hunting or whatever, and then they'd come back and tell the group, or gossip. Gossip used to be a very big source of information before we had all of this kind of electronic information and even print information, because gossip would be, you know, I went to the town 50 miles away to go sell my cattle or whatever, or to buy supplies, and now I'm coming back to my rural community and, you know, everybody's asking me, oh yeah, well, so what's going on? What's happening there? And so we would get news and information from a particular person, and obviously that's colored by the things that they have seen, because you can't experience, right? If you go to LA and then you come back from LA and your friends ask you, you know, so what's going on in LA? What did you see? What's happening? You only know about the things that you saw. And so from the places that you went, you don't know what's going on in LA, quote unquote, everything that's going on. You only know a limited amount. So nowadays we have to deal with, and so in the past, we've always had kind of a dearth of information, a lack of information coming in. But now with the advent of the internet, and more recently with the advent of smartphones, which are just basically little computers that we carry around with us all the time, we have to deal with information overload. And so there's been some studies about, you know, how much information can a human being actually cope with? And so in this instance, we're going to put it in terms of a computer. So I'm going to talk about bits and bytes a little bit. So how a computer works. And in order to do that, I'm going to use a whiteboard. Hey, look at that. So can everybody see my whiteboard?
Yeah.
Yeah, okay, awesome. Because I never know, I press share and I always want to double check to make sure that you're seeing what I'm seeing. So the way computers deal with information, and you may have heard this term, they're digital devices. So we talk about digital information, the digital information age. And what does that mean? Well, what's the opposite? Does anybody know what the opposite of digital is?
Analog?
Analog. Yes, very good. So I'm going to use my pen and draw on my screen, so I have to kind of hold it, otherwise it vibrates back and forth. So we have analog, and we have digital. So I'll just ask, can anybody explain analog? I know I can, but, well, I can give it a shot anyway. I don't know how good my explanations are. But what is analog? By the way, we live in an analog world, and we are analog creatures. So everything that we experience in real life is through analog. Logan, that's close, yes? I'll explain. Anybody else want to give it a shot as far as what an analog is? No? Okay, that's fine. How about digital? Oh, go ahead, Patrick. Go ahead. No, there's analog technology also. I have a record player. I'm sorry, Patrick, you locked it, froze up. Oh, you're unfrozen now. Okay. No, I know it's tough when you're driving, when you're in motion, because you never know what's going on. So what about digital? Do we want to give a shot for anybody want to give me a shot at digital? Logan's actually fairly close to what analog is and digital. No? Okay. So let me talk about analog here really quick. So yeah, don't get car sick, Patrick, by looking at the screen all the time. What's that?
A letter?
It's not a trick question, so feel free to answer the obvious question. Give me the obvious answer.
It's the letter A.
Mm-hmm. So it's the letter A. So here is the question. Why is it the letter A?
Because we were taught that this symbol is the letter A.
Very good. And that's using critical thinking. So I'm very impressed. Why is this the letter A? Because we were taught it's the letter A. It's just a shape, right? So if I do this, right, we all think that that's a 3, right? Why? Because we were taught that that shape is the number 3. We were taught that the other shape is the letter A. And there's something else that we were taught, and so that we infer from the letter, is that there is a sound associated with it, right? A or ah, depending on how it's used. Hopefully everybody remembers that. And when we see this letter, because we were raised where we were raised and we use this alphabet, that represents the letter A. And the only reason it represents the letter A is because we were taught it was. And at some point, somebody said, hey, this is an A, this is a B, this is a C. And by the way, this could be an A too, right? This is the letter, the number 3, this is the number 9, this is the number whatever. So, and this is a comma, right? We were just taught these things. You know, this does not have to be the letter A. We could have that as the letter A. Oh, I forgot the little thing there. Yeah, that makes it an A. Right? So we have to understand that the way things are represented in its analog form, and the way information is represented, in by this case, I mean words and numbers, or letters and numbers, is just a random assignment of shapes. And somebody said, hey, you know what? We're going to use those 2 symbols for the letter A. Or a group of people in the past said, hey, this is the way we're going to do it. And the rest of us went, that sounds fine to me. So analog really means that, or is really defined as the input being proportional to the output. So when I move my arm, so I'm going to try to get my screen here. There we go. So when I move my arm, and let's do this. Here's my finger, the tip of my finger, right? And I gotta do this right. It's much easier in the classroom. So I'm moving my finger. Okay. Now I'm not doing this with my finger. I'm moving my finger. I'm actually moving my whole forearm, I guess. But it's the motion of my finger, the arc that my finger makes, the distance that my finger travels, is dictated by what? He asked and expected answers. What's it dictated by?
The motion of your forearm.
Okay, so the motion of my forearm. And what is the motion of my forearm dictated by? We'll get there.
Your brain.
I'm sorry?
Your brain.
My brain? Yes, my brain is doing something, but what is my brain controlling?
The elbow.
The elbow. Is that right? What's dictating how far I guess my elbow is dictating how far it can go, because it can't go further down, right? It can't, if it bent this way and it kept going, right, then you'd all be grossed out. And you'd all go, oh my God, I'm never coming to his class again. Yeah, my elbows are not double jointed. So Logan actually has the right answer. He said biceps. So what's causing my finger to move is that my forearm is moving. Now, the range of motion is dictated by my elbow, right? Because I can't go further than straight at, well, I guess I am a little bit double jointed. Look, that's kind of gross. Kind of bends a little bit that way. But it is dictated by my range of motion in my elbow. But in reality, what's causing my forearm to move, and by the way, I don't have to go all the way, right? I could just do that, is the motion of the muscle. My bicep here, it's not very big. I'm not Arnold Schwarzenegger, but I'm moving this muscle, and that muscle is causing my finger to move or to travel a certain distance. Now, is the distance that my finger moves greater than the distance that the muscle moves? Logan's the only one that wants, oh no, other people want to play too. Okay, good. I like it when you all play. So the answer is yes. I have my chat room up. So Ezra says yes, and Valerie says yes. Awesome. And that's fairly obvious. But here's the thing. Is the motion of my finger proportional to the distance that my muscle moves? I don't want to keep doing this. So I'll just pretend this is my forearm. right? Is it proportional? Yes, is also the answer, right? So when we, and by the way, I forget who said that it's wave-like, and where was that? Analog is wave. So Nicholas, that was very good. I meant to praise you earlier for playing, but I forgot. So you can see that the output, which is the movement of my finger, is proportional to the input, which is the movement of my muscle. So if my muscle moves, and by the way, we're all a little bit different. The lengths of our muscles are different, and our upper arms are different lengths. And my finger, your forearm to your finger, your elbow to your finger, I guess, is a different length. So, but all of us, if our muscle moves, say it moves an inch, that's going to cause a certain amount of movement here. So that means that there's a proportionality. So I don't know what it is for me, but let's say that if I move my muscle an inch, so if I contract my muscle an inch, my finger is moving 4 or 5 inches. So let's just say it's 1 to 5. 1 inch equals 5 inches of movement. So therefore, if I move if the muscle contracts 2 inches, it's going to move, my finger will move 10 inches because it's proportional. So it always stays the same ratio. Does that make sense? Also, you guys hear me speaking, right? You hear my voice. Now, we all, or most of us, could have a voice. We can speak. So what dictates, say, the volume of my voice? How loud it is that I talk? What is dictating that? I hear ones and zeros, okay? But we'll get there. So what dictates how loud my voice is? Lung capacity, your lungs, your vocal cords. Now put the two thoughts together. Lungs, what do lungs control? And what causes the vocal cords to work? The diaphragm, okay, we're getting close. The respiratory system, you're getting further away. What are we doing when I'm talking? What am I doing? What's the other thing that I'm doing? Yes, Anthony. Yes, Ezra. Yes, Brian. Yes, air, right? I'm forcing air. So when I'm talking, I'm actually breathing. And when I'm talking, can we talk when we're breathing in? I don't know. I guess I can. Let me breathe out. I guess I can talk when I'm breathing in. I guess I can talk when I'm breathing in, is what I said. It's more difficult to understand what it is I'm saying. It doesn't sound painful, but you really have to kind of think. Gross. I don't know if it's gross. But try it and see if you can do it. But so it's the air, right? The more air I force over my vocal cords, the more they vibrate, the louder I sound. And the less I can say, by the way. The quieter I talk, the less air I move through my vocal cords. And so again, there's that other thing that, well, we're moving, Valerie, we're moving the air in the opposite direction, and that's really not how we're designed to work. So we get a different, we have a problem, because let me put it this way. There's a lot more to talking than just moving air through the vocal cords, right? It's the air, we shape our, the shape of our mouth and our tongue moves, right? And that's how we enunciate certain things. So when I'm pushing air or pulling air in, really my mouth and tongue and the shapes are not working exactly the way they're supposed to work, the way they're designed to work. And so I sound a lot different. And plus, because the air is going in the opposite direction, I'm just guessing, it affects the timbre, the tone of my voice, because a deep voice or a higher voice is dictated by the length of your vocal cords. So I have a very long neck. I wonder why my voice isn't super deep. Never thought about that before, but anyway. Excuse me. So my volume is dictated by the amount of air that I push through my vocal cords. And we use our diaphragm to do that, etc. So most of you got all of this right, airflow, yes. So that's another example of analog. Now, what happens in the air? The air, our vocal cords cause vibrations, right? And those vibrations go out into the air, and so they cause the air to vibrate, and then they get received by our ears, and our ears have, it's called an eardrum, and that vibrates, and then somehow magically that gets translated into our brain as something that we recognize and we can then understand, as long as it's the same language that we speak. So, and by the way, the further away from you, from someone you are, at some point you can see them talking, but you can't really hear them. Sight is another analog. By the way, all of our senses are analog. Sight, why do we see, why is something blue or something red? It's because that's the color that is, so we know that white light is a combination of all colors. And when you see my white stripes here, you see that because all colors are being absorbed. And so, is that right? No. All colors are being reflected. Yes.
I think so. Yeah, because black is the one that gets absorbed.
Yeah, black is where everything is absorbed. So I got that backwards. So yeah, thank you for helping me, because sometimes I don't remember everything the way it's supposed to be. Yeah, so white, everything is being reflected, and so I see white light because the white light is a combination of everything. This is actually not black; it's dark blue. I don't know how if you can see it, but this shade of color is being reflected. The rest of the light spectrum is being absorbed by the shirt. So that's why we see this particular color. So that's analog. And by the way, colors have names, and they're represented by, I don't know how to put this, colors, right? So behind my white screen, I have this light blue or different shades of blue kind of background. And I see that because actually that's a little bit different, isn't it? It's a light emitting. So displays work a little bit differently. But my point here is that colors and letters, when we go to data representation in an analog form, are represented by characters. And the easiest way for me to do this is to use characters. So to use a letter like the letter A, for instance. So when we translate to a digital, and by the way, yeah, when we translate to digital, what is digital? So here, let me do this. Let me click undo a bit and get rid of some of this stuff down here. There we go. So let's look at how data is represented digitally. With a computer is first and foremost, there's all kinds of analog sources. Radios are kind of analog, although FM has moved to digital. It's all about how data is transmitted. So whether we use waves or whether we use what I'm about to talk about. So let's talk about how I would represent the letter A in a digital form. Now, computers are, in order for a computer to work, it needs what? What does it need? In order for a phone to work, what does it need? And I know that's a little bit of a vague question, but think about what it is that you have to do in order for it. I'm sorry?
Charge it.
Charge it. And another way to say that would be?
Electricity.
Electricity. Yes, even before we have a motherboard or we learn how to use the device, it needs to be powered, right? It needs power, which is the bane of all of our existences with our phones, because they, you know, oh, damn it, I'm at 7%. It's going to die. I'm not, right? Where's a plug? We all walk around all of our days with damn charging cords and stuff. So, oh, I just need a place to plug this in. So it needs power and it needs electricity, right? That's what we use. And electricity has two states. So what two states are there in like water has, how many states? 3? Solid, liquid, gas, right? So ice cubes or ice, liquid water that you can drink, and gas, I guess, fog, mist, steam, right? That's the gaseous form of water. So it has 3 states, but electricity has 2. They are very simple, actually. So when you stick your tongue into an electrical outlet, one of 2 things can happen. What are they? Ah, Anthony got it. You're either getting electrocuted or you're not, right? Because either the electricity is on and you are getting electrocuted and wondering why you shoved your tongue into the outlet, or you're not and you're going, and you're also wondering why you shoved your tongue into the outlet. So there's a switch, like a light switch, right? So the electricity to my overhead light is on, and I press the button and nothing happens. And now I press the button again. And the electricity to the light bulb has, or bulbs, I think there are 2 or 3 in there, has been turned off. Yes, exactly. So the switch is getting power, but it dictates whether the power keeps going from the other side. So you turn it on and the power flows to the other side and it goes to the light bulb, or you turn it off and then it stops it at the switch. So the switch is always hot on one side. So you have to be careful when you have a uncovered switch. So I'm gonna, see, it's so dark today. Wow, yeah, I better, I know that it kind of blows out your guys' screens because it's so bright. But anyway.
I think it's maybe because of the fire that's going on. That's why the light's all weird, at least where I live.
Well, it's very overcast this morning, and it's not supposed to burn off until like 11 o'clock. And I'm just surprised because it's also not very hot right now. But it is supposed to get up to the mid or upper 90s today, I guess later on. So it's like we're living at the beach. We have overcast this morning.
Oh.
Yeah. I know that yesterday there was a lot of smoke in the air, and the day before there were actually ashes falling down at my house. Although I don't live close to it. I live in San Bernardino. I live, if you're familiar with campus, if you've ever seen it or you know where it is, I live about 4 miles from campus, west.
Off campus.
East. Yeah. So yeah, that's right. The housing is still there. Okay. So yes, yes, Valerie, you are very correct. A gender reveal party. I don't know why you have to have explosives when you reveal what your gender is. And I'm not going to go into the.
That was in my city.
I don't know how. gender reveal works, do you like have a robe on and go 1, 2, 3, yay, it's me? No, it's a baby. I know. It's a boy. But yeah, does the baby really need fireworks? Probably not. So anyway, the baby was walking around going, hey, guess what I am? Whoop. No, so anyway, let's get back to digital data representation. So computers and electronic computing devices use electricity to send information from one place to the next. And since electricity has two states, on or off, we represent that with zeros or ones. Sorry, a 0 or a 1. A 0 represents an electronic off state, and a 1 represents an electronic on state. And by the way, in storage, most of the time we're using some kind of magnetic storage. So a 0 would be a negative, right? If you have two magnets and you put them together, sometimes they attract. And if you turn one of them, then they kind of repel each other, right? So magnetism is either positive or negative. So having said that, we represent in the digital world, this is called a bit, by the way, things with bits. Now, how many, let's say that I want to represent the alphabet, and I'm going to use a 0 or a 1 because I have an electronic on-off state. So how many characters can I represent?
2.
2 is the correct answer, right? The 0 could the off state could represent A, and the on state could represent B, and then I'm done. So this isn't very useful the way it is. So what we end up doing is we combine bits. So we combine zeros and ones into bytes. And a byte is a set of, or a group of zeros and ones. So a byte is at least how many bits?
2.
Yes.
8.
So a byte is at least 8 bits. Now, sometimes, and I say at least because sometimes, and I know that my writing looks like I'm in like 3rd grade, but it's just because of the whiteboard. So the reason I say it's at least 8 bits is because sometimes our bytes are more. So we use more than 8 zeros and ones combined. So let's see, 0, 1, and I don't know, I'm just making this up. 1, 2, 3, 4, 5, 6, 7, 8. So this would be a byte. And this chunk of on-off states, zeros and ones, this set of bits could represent a letter, or it could represent a particular color. Now, each one of these has, so each place here has 2 options for me, right? So keep that in mind. So basically what I have is 2 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 options for each one of my placeholders, so 8 of them, right? So it's 2 times 2 times 2 times 2, so it's 2 to the 8th power, which is easy to calculate. It's 256 individual things that I can represent if I use an 8-bit byte. 2 times 2 times 2 times 2 is 256. So which is perfect for, say, the alphabet and numbers and characters, like an exclamation point or comma. How many emojis are there? Does anybody know? Are there more than 256 different emojis? Too many. Way too many. Okay, so there are more than 256. So in order just to represent each emoji, more than 10. Yeah, I know that there are more than 10. Oscar's like, oh, there's more than 3. I have more than 10. Google says 2,666. Ooh, 666. Okay. So in order to represent every emoji, I can't use 8-bit bytes, right? So I have to use, and the same thing holds true for colors. There are more than 256 colors. So I need to use bytes that, holy crap. Okay, so we have around 3,000. Say there are 3,000 emojis. Let's everybody chill on the, no, there's 3,304 as opposed to 3,136, or 3,178. I think that's how many poop emojis there are. But anyway, so having said that, when we need to represent more data, like emojis, we need to have bytes that use more bits so that we can represent more data. So if this is 256, if I do 12-bit bytes, that's 2 to the 12th, although we typically don't use 12-bit bytes, so I shouldn't do that. We typically go to the next, we double this number. So it'd be 16-bit bytes. I think with 16-bit bytes, we can go up to, oh, damn it, I've forgotten. I used to know that number offhand. My chat is in the way. What does it say? 16-bit bytes. Damn it. I maximized my screen and now the top of my web browser is going away and I can't get it back. Unless I move it over here. I can't move it. Oh, never mind. How many are there? 65,000? Yes, okay, thank you. So there's 65,000 possibilities, so that's more than enough to cover my emojis. Are there more than 65,500 shades of color?
Yeah,
Yeah, there are.
because can I add on?
Yeah.
So there's also shades of color that that we cannot see, but they do exist. Just because we can't, physically see it, doesn't mean they don't exist. Because there are people who can see colors that we can't, but that's more on the lower percent chance that you have.
That's very true. That's very true, Valerie. But if most people can't see them, do we really need to record them? Right? So my point is that this might seem like a shade of color, but if you look at my shirt right now, it is one shade of color. But our eyes, and you should be seeing it as multiple shades of color right now, because the light and the shadow, where the light hits it is lighter, where the shadow is darker, right? So when we take a photograph and we draw a painting, you don't like fill in somebody's clothing with a block of this exact same shade of the same color. Otherwise, it doesn't look realistic. So I don't know. There's a bunch of shades here because of the folds and the creases cause all kinds of darker and lighter spots. Very rarely do we have something that is uniform. And even this isn't uniform. It's a page of paper, so it should be fairly uniform white, right? But it's not, because you can see where the light is hitting it. So it's a lot lighter. So there are 18 decillion colors, including the ones we can't see. Now, having said that, we can only really see 24 million shades of color. So, and by the way, 4K resolution is the highest that we can really see. So we're limited by our eyes. We can record more colors, by the way. So a lot of times when you're using a camera or something, they're using 24-bit bytes or 36-bit bytes. With 24-bit bytes, you can record like 16 million something or other different shades of color or characters, or each byte represents one piece of information. Okay, so having said that, oh crap, it's 50. So let me stop there. Today we will have labs. I'm sorry, Patrick. Let me stop sharing this really quick. Oh, come on, where's my cursor? Stop share, there we go. So we will have labs today because I want to continue talking about what it is that we're talking about. That's one. Two, there will be a lab assignment, which I will give you on Thursday. Basically, it's a homework assignment. So you're going to have to do a critical thinking exercise and write up some stuff and then just send it to me. But we'll talk about that on Thursday. So are there any questions about anything? No, are we good? Okay, so lab starts at, the first one starts in about a half an hour, I think. Like it's 10, is it 10 or 10:20? I forget.
10:30?
Do we know? 10:30? Is that when it starts? 10, well, I have this stupid, here, let me click back. And then I was at Chafee. No, I was at CSUSB. And
It starts at 10:30.
at 10:30? Okay, awesome. I will trust you guys. So I will see the first group of you back at around 10:30. And then the rest of you, you can kind of, and remember for this kind of part of the class, you can jump to whatever lab that you want to go, or whatever's convenient right now. When we actually have assignments, when we're doing programming, you may have questions, so I like to have smaller labs so that I can answer questions easier and get to everybody. So, but you can still kind of jump around. I just don't want everybody like in one, like all 70 of us are in one lab. Okay, so having said that, I'll see you guys later. Unless you have questions, I'm going to stick around for a couple minutes. We'll see you later, Patrick. Have a good trip. Be safe. So I'm just going to stay here until everybody's gone.
Professor, I have a question.
Uh-huh.
Are you working out of the book?
No, we're not in the programming book yet. Okay, we're going to get there. We're going to start working next week.
Okay.
Out of that, this whole critical thinking part, I'm just working from my notes and kind of some stuff that I got off the internet and kind of have conglomerated. So there is no reference other than the lectures.
Okay.
There won't be a test on this material, but you know, I do expect you to use it, and we'll, again, on Thursday, during lab, I'll talk about what it is that I expect you exactly to do, and I may go over a couple of things that you need to use in order to do the assignment, just to refresh.
Okay, so I could get started. What chapters are you going to start with?
In the book?
In the book.
Okay, so our first assignment on Thursday is going to be a critical thinking exercise.
Right.
So we're not going to actually start working in the book. Yeah, I'm having a problem with this. I got to fix that. Yeah, but we're going to start with chapter 1. So if you go to the syllabus, you'll be able to see exactly what it is that we're going to cover. And you can see that we're really we're not going to actually do any programming even next week. We're going to get ready to do programming and talk about critical thinking kind of pointed into the programmer's kind of brain, more problem solving kind of a thing. Okay? But a lot of that
Okay,
problem solving
got
stuff
it.
from the first chapter of the book.
Okay. Thank
Okay.
you.
You're welcome.
Okay, see you later.
Bye-bye.